Alrighty, 4.6, solving systems by graphing. We have done substitution and elimination. We have one more way we can solve systems that we're going to do with graphs using our calculator. So I hope you are comfortable with your calculator, but we'll find out. So remember that when we have systems, we can have one solution, which is two lines crossing. We can have no solutions, which are parallel lines. And we can have infinite solutions, infinite, which is actually two lines that are the exact same line. Okay, so I'm going to go back and forth between my notes and my TI calculator thing that's on my screen. So you're going to have to be patient. Okay, so, but to use the calculator, you're going to have to put it in the equation as y equals, because you know in your calculator, it's y equals. So let's go ahead and solve for y. I'm going to subtract 2 over 5x from both sides, which leaves me with negative y equals negative 2 over 5x. And I can change the signs, make them both positive. The second one, I'm going to subtract 3x. And I end up with negative y equals negative 3x plus 13. And that would be y equals 3x minus 13. Okay, so I'm going to go to my calculator. So this is what the front of your calculator looks like in your little screen. So let's go to our y equals. So push y equals. Clear out if there's something in there. Put in 2 over 5, and I'm going to use my alpha y equals, enter, to get a fraction. And I'm going to have 2 over 5 x, and that's all. Okay, then I'm going to hit enter and go down to y2. I'm going to put both of these in. This one's going to be 3x minus 13. All right, so I have two equations in here. If I want to, I'm going to go ahead and turn the plot off up here at the top by hitting enter, because I don't want that on. If I hit graph over here, I have a weird window. So when you have a weird window like this, and nothing's showing up, let's try Zoom 6. Zoom 6 is standard resets the window, you can see right here. All right, there's my two lines, and they are crossing. So now let's go to second graph. So second graph, I'm going to have to remember to tell you that. And I'm going to write this down, then I'll go back and fill it in on the table. So let's start with 3. So 3 is 6 over 5 and negative 4. 4 is 8 over 5 and negative 1. 5 is 2 and 2. And 6 is 12 over 5 and 5. Okay, let's go back to our worksheet and fill that in. So what I did with my graph was, I think it's down here somewhere at the bottom. Is it? I'll tell you. There it is. Okay. So let me go ahead and fill that in. So number 3 was, for 3, notice I had y1 and y2, and I just copied them down. y1 is going to be this one, and y2 is going to be this one. So my y values for x equals 3, y equals 6 over 5. 4 is 8 over 5. 5 is 2, which would be 10 over 5. And 6 is 12 over 5. And my other line had negative 4, negative 1, 2, and 5. Okay, so you can tell that 5, 2 is an ordered pair by looking at that. And I just totally skipped the whole how we would not use our calculator. But anyway, so there it is right here. When our x value, when x is the same for both our y1 and y2, and that's the solution. So this is a solution. We could check it by substituting that in for x and y. I'm going to change colors here real fast. Maybe I don't like that color. I want that color. Choose red. Okay, so I could take equation number 1 and I could put 2 over 5 times 5 minus 2 equals 0, which doesn't show up over there. So when I have 2 over 5 times 5, that's 10 over 5 or 2. So I have 2 minus 2 equals 0. Yeah, that's right. And then I would also have to put it in this other one. So I would put 3 times 5 minus 2 equals 13, and that's 15 minus 2 equals 13. So it also works if I substitute in that I can see that that ordered pair is a solution because it is on both of the lines. Okay, so let's do number 2. All right, I'm going to graph these by hand, and that's pretty easy to do because I can put in some values for x and y, but I know that y equals x is my parent function. I hope you said that. Okay, so I can put in 1, let's put in -1, 0, 1, and 2. So y1 is going to be exactly the same numbers because y equals x. The second one is going to be, if I put -1 in, -2 times -1 is 2. Minus 3 is going to be -1. If I put 0 in for x, y is -3. If I put 1 in for x, I have -5. And if I put 2 in for x, I have -7. So let's go ahead and I'm going to try to put the points on here. So I have 0, 0, -1, -1, 1, 1, 2, 2. So here is my parent function, y equals x. And if I'm really good, I'll use a different color for the next one. So I'll do y2 in green. Okay, so I have -1, -1, and I have 0, -3, and I have 1, -5. Okay, so that one's going up -2, which is my slope right there. So I can go up 2 over 1, up 2 over 1. So here's my y equals -2x minus 3. Okay. And I can see that the solution is -1, -1, because that's where the lines cross. So let's go back to our calculator. I guess just because we can. And I'll show you that again. Let's go to y equals, clear out the equations. Okay, go back up to 1. y1 is x, enter, and the next one is -2x minus 3. Okay, second graph. No, not second graph. Let's just do, well, okay, second graph. Let's just do graph. There's my graph. Okay, I'm looking for the place where they intersect. And to do that on the calculator, I'm going to push second trace 5, because I want where they intersect. And then it's asking me which lines I want. So I'm just going to hit enter for first curve, enter for second curve, enter for guess. I'm not going to guess. I'm just going to let it guess for me. And my intersection, oh, look at that. Is it -1, -1, which we knew because we had that. Awesome. Okay, or you can go to second graph and look at the table and go through until you find where the x's and the y values are all the same. So Our answer is -1 and -1, which we already knew. But now we have confirmation. All right, so number 3. Oh, so here's where I write my solution right here, -1, comma, -1. All right, so we're looking for a solution to this one. So I have a couple things I can do. I could, I guess if I were solving by hand, I would hope I could draw a straight line, and I would extend the lines to see where they cross. Or I can look at the slope, which is up 2 over 4. So the slope is 2. No, up 1 over 2. So the slope is 1/2. So I could go up 1 over 2. Up 1 over 2. Up 1 over 2. Okay, and I could kind of extend it out like that. Since my lines aren't going to be straight, it's going to be hard to tell, but heck, we'll give it a try. All right, this slope is 1, -1 over 5. Oops. Okay, so I will go down 1, 1, 2, 3. Oops, 1, 5 will be right here. 1, 1, 2, 3, 4, 5 right here. 1, 1, 2, 3, 4, 5 right here. So somewhere in here is where my lines are going to cross. And let's just take a guess and say it's going to be 9, 2. But that's just a guess because I can't tell. So we could put the points on there that we see and see if either one of them looks like it's going to be on there. So 0, 4 would be up here. So while it is one of the points, it is not on both lines. 8, 1, possibly. 0, -3 is not on both lines. And 10, 2, see, I can't really tell from here. So let's go ahead and put these in our calculator and see. Well, I have to find the equation. So this one crosses at -3x. So I have 1/2 x minus 3. And this one is -1 over 5x plus 4. So let's go to our calculator. I guess I should write that down somewhere. Oh, I did. Okay. Let's go to the calculator. Let's go back to y equals. Let's clear our graphs. Okay, so y1 is negative fraction alpha y equals, enter, 1 over 5x plus 4. Our second equation is 1/2 x minus 3. Let's graph them and see what happens. I might not be able to tell on here. Okay, the thing about that zoom, remember I was talking to you about second trace 5, is if I do second trace 5, which is the intersection, enter, 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 and it calculates, and oh, there it is, 10, 2. If it's off the screen, sometimes it'll give you an error. So let me go ahead and write down 10, 2, so I don't forget. Okay, so if it happened to have given me an error because it couldn't find where it intersected because it wasn't on the screen, then I would have done zoom 3, enter, which basically just zooms out. Okay, and then I could do second trace 5, enter, enter, enter. Oh, there, I messed up. Okay, and there's 10, 2 again at the bottom, and you can see where it says intersection. If it doesn't say intersection, you didn't hit the right buttons. So make sure you're paying attention. Okay, back to our notes. So D is our answer. Alrighty. So using a calculator, we've just done all this. So things to remember are Zoom 6 resets your window for the graph, and Zoom 3 zooms out. So if you need to see more of your graph, Zoom 3. Okay, so let's go back and let's finish. Let's see if we can find our solutions for 4 and 5. So y is already y equals. I mean, the first one's already y equals. Second one, I need to subtract 1/3 x from both sides. I end up with y equals negative 1/3 x minus 1. Go to my, well, I should write that down to my, before I go somewhere. All right, so then I go back to my calculator. Y equals, clear, clear, x minus 16. And the other one is alpha, y equals, enter. So I can put my negative up here if I want. Negative 1/3 x minus 1. Graph. Okay, now I have my zoomed out graph, which is fine. I'm going to do second, trace 5, which is intersect. Oops, not 6, 5. Enter. First curve, enter. Second curve, enter. Guess, enter. And then I find my intersection is the point 11.25, comma, negative 4.75. Alrighty. Go back to our worksheet. Lots of back and forth. The solution is 11.25, comma, negative 4.75. Okay, there's a decimal over there somewhere. Okay, for number 5, I'm going to have to add 1.6 to both sides. 1.6x. So I'm going to have y equals 1.6x minus 5.34. I'll go back to my calculator. Y equals, clear amount, 4.7x plus 2.1. Enter. 1.6x minus 5.34. Graph. Alrighty, so they do cross, so there is a solution. Zoom. Nope. Second. Trace. Sorry, I got mixed up. 5. Enter. 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 And my answer is, I don't know what. Enter. Try that again. There we go. So x is negative 2.4 and y is negative 9.18. So we'll go back to our paper. And I'm going to change colors because I like the board with the same color. So my solution is negative 2.4, comma, negative 9.18. All right. On to this page. Okay, you guys have this equation over here underneath number 6. So I already moved it over. So just scratch out the equation that's over here and write it over here because those two go together. Okay, so we are finding the solutions. We can graph them. So if I wanted to, well, first of all, I'm going to divide both those by 2 because that's easy. Y equals 2x. So it starts there, and I go, when x is 1, y is 2. When x is 2, y is 4. So here's my line. And then my other one's going to be, I can substitute in, but I'll go ahead and solve. So I have minus 2y. I took 4x away from both sides. So negative 2y equals negative 4x plus 4 divided by negative 2. And I end up with y equals 2x minus 2. So that one's going to be, I bet it's going to be the same. It's going to be parallel. And there's going to be no solution. But we'll put it in our calculator. Just one sec. Okay, so I'm going to write that down. Y equals 2x minus 2 and y equals 2x. And why do I think they're parallel? Because I drew it. Why is the other reason? Same slope. Same slope. Parallel. No solution. I don't know why I'm writing it down because I'm just going to tell you that that's what it is. So, okay, no solution because they're parallel, because they have the same slope. All right, so let's do this one. Subtract x minus x. 2y equals negative x plus 4. Y equals minus x over 2 plus 2. And this one is, I'm going to run out of room. Y equals 5 minus 2x. And so I just wrote all those in different ways because I can put any of those in my calculator, and my calculator knows what to do. So I'm going to go ahead and just solve all these. Or I could put them on the graphs. I guess I could put them on the graphs. Yeah, heck, why not? Okay, so this one's going to start at 2 because it's hard to on here, and it's negative 1/2. So I'm going to go negative up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. So there's that one. And my other one is going to be, starts at 5, and it's a negative 2 slope. So it's going to go down 2 over 1, down 2 over 1. Oh, there's going to be right there. Down 2 over 1, down 2 over 1. So there we go. Okay, so my solution is going to be 2, 1, because that's where they crossed. So it's nice when the slopes meet at a pretty point, and they don't always, but for these they do. All right, so let's look at this next one. I have minus 3x, negative y equals negative 3x plus 2, y equals 3x minus 2. Your other one is going to be negative 4y equals negative, I always run out of room, 12x plus 8, divide by negative 4. So I end up with y equals 3x minus, dang, look, it's the same. Same equation, same line, infinite solutions. Alrighty, that was easy. Okay, so we have a set of linear equations. We just need the x coordinate, but we'll probably end up finding both of them. Okay, so let's do 0.6y equals negative 4.8x plus 4. Divide everything by 0.6. And I end up with, y equals negative. Somebody tell me what is negative 4.8 divided by 6. Negative 0.8 plus 4 divided by 0.6. Oh, 6.66666 and 2/3. Alrighty, and then our second one is going to be y equals negative 3.2x plus 2.7. I'm totally going to go put those in my calculator. All right, calculator. Y equals clear, clear. Y equals negative 0.8x plus 6 and that didn't work right. 2/3. I'll go back to the beginning and put my 6. Okay, so there's that, and then my other one's going to be negative 3.2x plus 2.7. Graph. Second, trace, 5, enter, enter, enter. Okay, so my intersection is negative 1.65, comma, 7.99. So round to the, ooh, it said round to the thousandths? So I need to put one more number. Okay. Man, we're almost done. Okay, quick. So my solution is red, negative 1.652, comma, 7.989. Rounded to the thousandths place. All right, last one. So let's write our equations. We have, what do we have? We have total cost. And we have H, how many hats? So for the first one, hats off, I'm going to have the total for hats off. I'll put HO over here. Equals 5x plus 50. And for top stuff, the total is $6 plus $25 for the setup. Okay, so we need to look at when the cost is going to be the same, and we're lucky that, first of all, I put x's right here, and our t can be our y, right? They're already set up correctly. So let's go to our calculator and see what is the magic place where they cross, where the hats cost the same amount. Okay, so I have, man, I just erased, okay, so I have y equals 5x plus 50. And the other one's going to be 6x plus 25. Graph. Okay, these look kind of crazy, don't they? Well, let's see what happens if I do second, trace, 5, enter, enter, enter. Oh, it worked for me. On your calculator, it might have given you an error because at x equals 25 hats, y equals $175. I think on your yellow calculator, if it's not on the screen, I think it gives you an error. I'm just going to see if I can do this real fast on calculator and compare. So we have 5x plus 50, and we had 6x plus 25. Yeah, see, that's just not even, and even if I do a zoom 3, so it looks like what's on the screen, which I did. If I do second trace 5, enter, enter, enter. Oh, no, it does give me, okay, I was wrong, I lied. All right, okay, so for 25 hats, it costs $175. So either company, if you buy 25 hats, it costs exactly the same amount. So when is it cheaper for the soccer team to use one or the other? So if the soccer team is buying less than 25 hats, use sheesh, top stuff. And if you're buying more than that, you should use hats off. If you're buying exactly 25, it doesn't matter. So there you have it. Hope this was helpful. Don't forget to fill out your Google form. See you Monday.